What is a network? So I want you to think of this as like the mail system. Think of FedEx, UPS, and DHL. They're all getting packaged delivered, just they do it a little bit differently. And think of the neighborhoods. You have 3 different types of neighborhoods there. You have one with a standard street with driveways to each house. You have like a cul-de-sac, it's a little bit different. You have like an apartment building where you have one major address, but a lot of sub-addresses underneath it. So think about addressing just like your home mail system, and I think you'll see that it's very similar. So any node on a network, it's called a node, but it's just like a house address. You really want your mail only going to you and not to your neighbors. The connections that tie the nodes together is called a bus, like a street, and the nodes communicate to each other by sending them ones and zeros and bits in serial patterns, just like mail. So why do they use this? They wanted to really make the machine simpler, reduce the wiring time, reduce the amount of wires, ease of troubleshooting, and point of use for the manifold and I/O. It reduced the reduction of junction boxes because now you have a single cable, and the I/O cards in the PLC are no longer needed. So if we look at just a single wire off of a master, you have one cable between the PLC, the controller, the valves, and the sensor. Again, it simplifies all the wiring. So how do you use it? We're looking at the PLC once again, and inside there you have I/O cards, but you also have controllers and you have communication modules. The communication module could be called a master, a scanner, a controller, or adapter. They're all meaning the same thing. So now that we have network basics, let's talk about protocols. So these are some terms that you're going to hear out in the industry. Profinet, Ethernet IP, and EtherCAT. So think of them as German, Japanese, and French. You're all translating data, but you're all doing it a little bit differently. So I can't talk Ethernet IP to Profinet. I have to use a translator to do that. So usually the networks are set up, it's all connections must speak the same, and they must understand the same language. But the protocols now can be divided into 2 different groups, open and closed. An open protocol is where a group of people get together, come up with a specification, and as long as manufacturers meet that specification and go through a conformance test, they're considered they can sell their product. A closed protocol is where a single company would define a network protocol, and if you want to be on their network or use their protocol, you have to pay them a royalty. So it's not as easy to use, and you're not going to get many companies that want to go into a closed protocol because they have to pay a royalty. So open protocols are usually the best. So now we're going to talk a little bit about topology. Topology is the way things are connected. So we had protocol on how the different terms are being used for the different types of language, and topology is the way things are connected. There are strict rules regarding topology on the length of cable, the type of connectors, so each field bus has strict rules on how things are connected. There are 4 basic topologies that are used. A linear trunk and drop is just sort of like our standard street address. A star topology, ring, and a point-to-point, which is a master-slave, which is like used for I/O link. The street would be called sort of like our trunk line. Each driveway would be a drop line, and each node would be a house. So again, this looks just like a standard street that you'd have in any normal neighborhood. This is a ring topology. Say we cut that section. Information could still flow to all the different nodes because of the ring. It goes, if it can't go one way, it goes the other way. You have star topologies, you have tree topologies, and you can even have wireless. Again, a point-to-point master I/O slave is going to be I/O link. It has a slave and a master, or a producer and consumer, and it's a single point connection. So it doesn't have any tree topology, ring topology, or daisy chaining. We've started to see a big shift now towards Ethernet type networks. And the reason why is the cost came down. So all the DeviceNet and Profibus and CC-Link are now moving towards Ethernet strictly because of the cost. It's coming down, speed's faster, but we're also seeing there's a move towards I/O link because it's a common low-cost diagnostic type I/O network. So let's just talk a little bit about safety in networks, because you're going to hear more about that. Just as we described earlier with all the I/O, with lots of wires and lots of connections, they had safety relays. And a lot of plants still have a lot of safety relays, but that's a single point connection. So like a e-stop switch or a gate switch has two connections. Each time you push it, you have two connections that have to be made. That means all the wires, all 4 wires, have to come back to a safety relay. So really it costs a lot of time to wire in safety relays. So what we're seeing is a shift towards, just like we've seen from networks, we're now seeing the same thing in safeties. They're going into safety networks. So you have SIP safe, you have Profinet safe, and you have EtherCAT safe. So it's a move towards that IP65 or that IP20 safety PLC, and everything is coming over the network. But there are some catches to that. If I have safety in a network, I have to make sure that the I/O is still there, so they have a heartbeat, and it updates it about every 10 milliseconds to make sure that that network is still safe and the I/O can be controlled. Now we're going to talk briefly about plant floor architecture.